People often ask me, as a theoretical physicist, when will the universe unveil its next great mystery? My answer has never changed. That moment is happening right now. A traveler from the endless gulf separating distant suns, officially catalogued as 3IATLAS, is currently slicing through our galactic neighborhood at astonishing velocity. When it was first detected back in July, it appeared as nothing more than a fragile shimmer against the cosmic canvas, barely more than a statistical anomaly in background starlight. Yet today, that faint trace has evolved into something truly extraordinary. Before our very instruments, we are witnessing a real-time showcase of celestial dynamics, electromagnetic turbulence, and perhaps most profoundly, a test of human comprehension itself. At present, 3IATLAS lies less than 2 astronomical units from our Sun, racing forward at nearly 60 kilometers per second and still accelerating. During its closest solar approach, expected between October 29th and 31st, projections indicate peak speeds nearing 68 kilometers per second. Picture this: an interstellar voyager, expelled from some distant solar system, now plunging headlong into the blazing radiation belt surrounding our own star, an encounter no spacecraft of ours could survive. These next several days are mission critical. On October 3rd, 3IATLAS made its nearest pass to Mars, skimming within roughly 1/4 of the Earth-Sun distance. This unique alignment offers a priceless observational window. As Earth's telescopes grow temporarily blinded by the Sun's glare, Mars takes the stage, perfectly positioned to continue the vigil. The European Space Agency has 2 robotic observers on standby, Mars Express and the ExoMars Trace Gas Orbiter, both ready to capture high-resolution imagery and conduct spectrochemical scans. Meanwhile, NASA's orbiters, including the Mars Reconnaissance Orbiter with its powerful HiRISE camera and the MAVEN Atmospheric Analyzer, hold equally optimal vantage points. Although some data streams have fallen silent due to the ongoing federal funding suspension, other nations may soon fill the gap. China's Tianwen-1 and the United Arab Emirates' Hope probe could provide crucial corroborative readings, assuming mission control can redirect their sensor suites in time. Such synchronized observation is the essence of true science, separating speculation from measurable truth. So, what exactly are these instruments registering? Let's start with the most telling indicator: luminosity. 3IATLAS has already intensified to a magnitude 12 brightness, a remarkable escalation suggesting increased surface activity potentially due to volatile sublimation, plasma reflection, or something else entirely. Still invisible to the unaided human eye, yes, but now well within range of mid-tier amateur telescopes. Yet what truly captivates researchers isn't mere visibility, it's the sudden surge in brightness. A deviation that broke from our predictive models sometime in early to mid-September, precisely when 3IATLAS crossed the 2 astronomical unit mark from the Sunday. In simpler terms, it's glowing far more brightly than our equations ever anticipated. Some of this discrepancy can, of course, be chalked up to observational variables, differences in telescope aperture sizes, sensor sensitivities, and post-processing algorithms all influence how light from expanding vapor clouds is recorded and interpreted. But even accounting for those factors, the intensity remains anomalously high. Then came a breakthrough, or perhaps an enigma. On October 2nd, the Perseverance rover returned an extraordinary sequence of images during a roughly 9-minute nighttime exposure series. With stacked, long-duration captures, mission scientists noticed a thin diagonal streak cutting cleanly across the otherwise vertical star trails caused by Mars's rotation. The streak persisted across several consecutive frames, its shape and angle consistent with a fast-moving interplanetary body rather than a random artifact. Cosmic ray impacts don't create such structured traces. Nor do Martian satellites. Their orbital speeds and angles simply don't align. But this line matched perfectly with the predicted trajectory and velocity of 3IATLAS at that very moment. Could it be that, from the Martian surface, we've actually caught a fleeting glimpse of an interstellar visitor in motion? The resolution is limited, yes, yet the implications are staggering. This is how real science advances, through small, verifiable fragments of data, each demanding scrutiny, replication, and cautious interpretation. Now, we turn to a different kind of challenge: orbital geometry. On October 21st, the event known as superior conjunction occurs. Imagine the Sun positioned directly between 3I/ATLAS and Earth, forming an almost perfect line of alignment. From our perspective here on the ground, the object becomes completely hidden, lost within the blinding brilliance of the solar disk. It's one of astronomy's great ironies. We can now photograph the shadow of a supermassive black hole from across millions of light-years, yet we lose track of a nearby visitor simply because it passes too close to our star's apparent position in the sky. That's why the Martian observation window carries such immense importance. Mars, offset just enough from this line of conjunction, remains perfectly placed to continue the watch while Earth's instruments fall silent. In this fleeting overlap between sunlight, geometry, and fate, humanity's robotic explorers on another world may become our only witnesses to the next chapter of this unfolding cosmic mystery. Immediately following solar conjunction comes the defining moment, the perihelion passage, scheduled between October 29th and 31st, when 3I/ATLAS will sweep to within roughly 0.36 astronomical units of the Sunday. If this enigmatic traveler intends to unveil a second act, we'll see it here, whether through violent outgassing eruptions, structural disintegration, sudden luminosity flares, or unexpected dimming. Whatever occurs, the fundamental laws of thermodynamics and celestial mechanics will ensure that its secrets reveal themselves during this fiery encounter. Beyond perihelion, the European Space Agency's JUICE probe will take up the watch, launching an extended baseline monitoring campaign from deeper inside the inner solar system. The geometric alignment is favorable, though the delay less so due to line-of-sight issues, telemetry scheduling, and communication bandwidth priorities. As a result, portions of this dataset may not reach public scientific archives until early 2026. That's the rhythm of discovery, a kind of cosmic relay, where one observatory hands its observations to the next, and the pursuit of truth demands months or even years of methodical patience. Now, step back for perspective. In less than a single decade, humanity has documented 3 confirmed interstellar visitors: Oumuamua in 2017, Borisov in 2019, and now 3I/ATLAS in 2025. Each one has broken a different rule of conventional astrophysics. And now, this third emissary from beyond our system has become both our subject and our teacher, revealing, in real time, how frozen alien matter behaves when awakened by the raw fury of solar radiation. It demonstrates how dust, plasma, and vapor can self-organize into sunward filaments, and how a comet's chemical envelope can activate in an instant, as if triggered by some biological reflex. That faint diagonal streak captured by Perseverance may be just a whisper of its immense kinetic power. Soon, spectral data from Mars Express and the Trace Gas Orbiter will help decode the emerald-green luminescence surrounding its nucleus. Are we witnessing familiar C2 swan band emissions, the classic carbon fluorescence of active comets? Or something entirely alien, a synthetic plasma effect born from photochemical interactions we don't yet comprehend? The evolving brightness curve will tell us soon enough whether this flare is a transient outburst or a sustained intensification as it dives closer to the sun's inferno. And beneath all these calculations lies something quietly astonishing. We, a fragile species clinging to a blue speck suspended in darkness, have engineered machines orbiting another planet to watch over a visitor from another star. For just a few precious days, those robotic eyes on Mars serve as our sentinels, ensuring that even from 140 million miles away, humanity continues its eternal vigil toward the unknown. When I was a child, comets were spoken of as omens from the heavens, as if the cosmos itself whispered warnings across the night sky. Now, I understand them differently, not as harbingers of fate, but as roaming laboratories, each carrying within its icy shell the physics of other worlds. 3I/ATLAS may never ignite into a brilliant streak commanding our sunsets, but hidden within the spectroscopic data, the layered exposures, and the geometry of its solar plume lies something far more enduring than myth or superstition truth itself. If you wish to witness how real science advances, watch this inquiry closely. Discovery doesn't emerge from bold proclamations, but from uncertain graphs annotated with error margins and humility. Progress doesn't come from certainty, but from the courage to be wrong, from the willingness to follow evidence wherever it leads, even into the impossible. In just a few short weeks, 3I ATLAS will pass behind the Sun, vanishing from our line of sight. For a time, it will slip into celestial invisibility, hidden by the glare of our own star. And then, come December, it will return emerging once more into the open sky, reborn after its searing journey through the solar furnace. When it reappears, it won't be the same object we once tracked. Its surface will have been scorched and transformed, its trajectory possibly altered, and its mysteries deepened. Yet in that transformation lies the essence of exploration itself, to send our gaze into the fire, to lose something for a moment, and to reclaim it changed, carrying with it the knowledge that we, too, evolve with every answer we dare to seek. We'll soon conduct a new round of measurements carefully, methodically, and with the patience demanded by deep space. Each observation will be compared against its predecessors. The subtle shifts in velocity, the evolving spectral fingerprints, the delicate variations in luminosity. We'll trace every change, every nuance, every unexplained fluctuation. There will come a day, perhaps sooner than we imagine, when some young doctoral researcher, years from now, will publish a paper beginning with these words: "We discovered something fundamental about interstellar objects through the study of 3I ATLAS." That paper will not just be a report, it will be a time capsule of human curiosity. It will cite the Martian orbital campaign, the image stacks from Namibian observatories, the Perseverance streak across the Martian sky, the brightness anomaly detected near 2 astronomical units, the emerald glow encasing the nucleus, the mysterious anti-tail structure defying conventional dust dynamics, and the perihelion behavior that challenged our understanding of celestial motion itself. Each paragraph will represent years of observation distilled into a single insight, another chapter in our ever-expanding encyclopedia of the cosmos. But that day has not yet come. Until then, we wait. We maintain our discipline, patience, skepticism, and above all, wonder. The universe does not owe us simplicity. It offers us something far greater: consistency. Within that consistency, physics builds its unshakable foundation. The equations hold, the constants endure, and yet within those parameters, mystery still finds room to breathe. We stand as a civilization poised between ignorance and revelation, a species whose instruments now reach from dusty observatories to the red sands of another planet. Our telescopes watch the skies. Our orbiters listen in wavelengths beyond human sight. Our imaginations extend even further, daring to ask questions our technology cannot yet answer. Somewhere, beyond the hum of computers and the cold of deep space, 3I ATLAS continues its silent path. Its shimmering plume stretches across millions of kilometers, whispering through the solar wind a cosmic message written in particles and light. It doesn't care whether we understand it. It simply is a testament to motion, to change, to persistence. And yet, by observing it, we do something extraordinary. We transform its existence into meaning. We translate cold data into insight, and insight into understanding. That is the essence of science: to find order amid chaos, to interpret the faintest flicker of starlight as a sentence in the universe's grand story. In the coming months, we'll continue to listen. The JUICE probe will gather telemetry, its instruments tracing subtle shifts invisible to ground-based optics. The Mars Reconnaissance Orbiter will compare post-perihelion emissions against its earlier captures. And from Earth, the next generation of AI-driven telescopic arrays will map the faint trails 3I ATLAS leaves behind, a breadcrumb trail through interplanetary space. Every signal matters. Every measurement, no matter how small, carries the weight of discovery. Perhaps we'll learn that the deceleration was an illusion, a quirk of perspective or data error. Or perhaps we'll find confirmation that something once drifted between the stars, and when it reached our system, it chose somehow to slow down. Either way, the implications are monumental, because even if 3I ATLAS proves natural in every respect, it has already expanded the boundaries of human perception. It has forced us to test the limits of our mathematics, our instruments, and our imagination. It reminds us that the universe's most profound revelations rarely arrive with explosions of light or thunderous clarity. They come quietly as shifts in numbers, patterns in noise, faint streaks across long exposure images, waiting for a mind brave enough to interpret them. So we wait, eyes fixed skyward, data streams humming, minds alert, and as we do, we remember. The cosmos does not reveal itself all at once. It speaks slowly, in the language of physics and patience. Our duty, our privilege, is simply to listen. Because someday soon, when the light of 3IATLAS reaches us once more, we may finally hear what the universe has been trying to say all along.